Hey, what is up everyone, and welcome back to another video. In today's video we are going to be looking at a very important skill to learn as a developer, whether you are a beginner or advanced, and this is Git and GitHub. So Git is something that a lot of developers kind of shy away from in the beginning of their learning phase, and it's actually something very useful and valuable to learn from the get-go. And I do believe that the 80-20 rule kind of applies to learning Git and GitHub, because just learning the basics covers about 80% of the things you'll always use and do with Git and GitHub. So in today's video, I hope I'll get you to start using Git and GitHub. And the idea behind this video is going to be, we're going to start with doing some of the basic Git commands and doing a workflow around that so that you can see how you actually use these commands. And then we'll move to a little bit more intermediate Git commands, and we'll do some workflow there. And then we'll start integrating GitHub with Git. So this tutorial is going to require you to actually have Git and GitHub set up and installed already. So I'm going to be linking down in the video description a blog article to a post where it explains everything around setting up Git and creating a GitHub account and connecting your local Git to your GitHub. So without further ado, let's get right into this tutorial. Okay, so for this tutorial, I'm going to be working within Visual Studio Code. I've opened the integrated terminal here at the bottom. I'm using Git Bash, and if you install Git, you have the option to install Git Bash alongside with it. So Git Bash is just a nice terminal that gives you Unix-like commands, and it works very well with Git as well. So that's a plus point. So I've just set up everything in Visual Studio Code. You can work directly from any terminal that your computer has. And yeah, let's get right into it. So basically, we're just going to do something very basic in the beginning to demonstrate all of these basic commands. So I'm going to create inside of this folder. So I'm in my desktop Git and GitHub tutorial. That's a folder on my desktop. I'm going to create a file in here called checklist.txt. So we're just going to be working with a normal text file. In here, I'm just going to add a few things that we're going to be learning in the beginning. So this is my Git and GitHub checklist. Whoops. Okay. And in here, I'm just going to add all of the commands we're going to be looking at the beginning here. So the first command we're going to look at is the git init command. The second command is the git status command. Third is the git add command. Then we have the git commit command. And then the last one for the beginning phase here is the git log command. So these 5 commands are actually probably the most used commands for any Git user. So they are very important to understand and know what they do and when to use them. So let's actually use them on this project or like folder file we are creating here. So a first very important piece of terminology that you'll hear a lot when working with Git and GitHub is something called a repo or a repository. Basically, this is just telling us that Git is tracking this project. So if I talk about the project, I mean this Git and GitHub tutorial folder. So basically Git, if you know and did a little bit of research what Git is a version controlling file tracking software that's free. You can download it. It was created by the creator of Linux kernel, Linus Torvalds. And yeah, it basically just tracks different versions or commits. So that's another word here inside of our project. So first, let's actually get Git to start tracking this project. So we can create a Git repository by running this first command. So inside of our terminal in the project, I'm going to say git init. And here we can say initialized empty Git repository in this directory, and then we can see it created a .git hidden file. So you can't see it here, but if I would do ls-la, we can now see this is just a normal command line commands, and then here we can see the .git file that was created. So this is basically Git marking that it should start tracking everything inside of this folder. So let's actually go on to the next command. So we have the git status command. So every time we want to check what is happening inside of our repository, we can use the git status command, and this will give us some helpful information with regards to what is going on. You can actually see Visual Studio Code has started to highlight files in color and give it this U and M and different letters in front. So it's actually very handy to work inside of Visual Studio Code. But anyway, let's run git status, which is the next command, and we can see this output. I'm gonna zoom in a little bit here. Here we can see git status, and we can see we're on branch master. We'll get to branches and how they work in a while. But here we can see we have no commits yet. So this is the commit command, and we'll get to creating commits in just a second. But here we can see the important thing we need to look out for here is the untracked files. So the untracked files is telling us that this checklist.txt inside of our repository is not being tracked by Git. So we actually need to tell Git, listen, okay, now that you have seen all of these files inside of my repository, I want you to start tracking different versions or tracking this file. So let's actually go and start tracking this file. So this is where the next command will come in, the git add. So we can say git add, and then git add takes in another piece of options. So the options can be the physical file you want to start tracking. So you can say git add checklist, or if you just want to track everything. So usually when you were to run git status and you have more than one file that's untracked, it would list all of them down here. So we can say git add and then just a dot. And then this would go and add everything. So now you can see the color has changed here, and it has an A for it's added. Or in Git terms, we talk about this file is now staged. So files go through like 3 or 2 processes in Git. The first, you actually just create the repository. Git tells you all of these files are untracked. Then you stage files, and from the staging area you commit them. So now Git has saved a version of them. So if I run git status again now, we can see the same type of response. We have on branch master, we can see no commits yet, and then we see changes to be committed. So use the git rm cache flag with the file name to unstage. So here you can see that word of unstage and stage. So this file is a new file. Git picks up its new, and this is the file name, and this is ready to be committed. So let's actually go and commit this file to Git and start tracking it. So this would come to the next command. So it's git commit, and this command takes in a flag, the M flag or the message flag. This is very important that you always have to, like, it doesn't work if you don't apply the M flag. So this will connect the message to this commit, and in here in quotation marks we can now add a commit message. So commit messages are something that it's important to make it as descriptive as possible. You don't have to write a book, but it's just descriptive as possible, so that when you go back in your Git logs, we'll get to that in the next one, you can see what exactly happened in that commit. So in this commit, we can say the following. It's the initial commit, and I'm going to say something here like created basic commands checklist. Sorry, my keyboard makes 2 spaces sometimes, but yeah. So this is this command. If I now press enter, we can see output being logged. We can see the branch we are currently on. So we're on branch master. In Visual Studio Code, you can also see it down here. And then we can see this is the root commit. So this is the very first commit of our project. We see the commit hash, and then we see the message we added. We can see how many files was committed and how many inserts happened. So if you were to check, this is line 7. So we had 7 lines of insertion. So it actually gives you like a pretty good analytics of what is happening during the commits and stuff like that. Okay, so here we can say see created mode with some number and then the file. So this created mode, I think this means non-executable file because txt is just a normal text file. But this is not important information to really worry about. Okay, so now we've covered all 4 of these basic commands. Now let's say you want to go and check out all of the commits that has happened inside of this repository and on this branch. So we'll get to branching in just a sec, but just bear with me. So now we're going to say git log, and here we can see output being logged. We can see the commit with the large commit hash. We can see something about a head pointing to master. We can see the author, and during the git setup in the blog, you would have had to put in these information pieces. So now it's getting used inside of your commit log to tell, okay, so Lloyd has created this commit. This is the GitHub email address he's going to be using. And this is the date and time that he made this commit. And then we have the commit message. So if you don't want to see this entire output of this long commit log, we can run a flag. So we can say git log and add a flag called one line. This will only give us like a short commit hash, still gives us this heads pointing to master and then the commit message. So you don't see the author and the created at date and stuff like that. So yeah, now we have covered all of the basic Git commands. So let's actually do some workflow around this. I'm going to add a new file. This is just going to be a dummy file, dummy.txt. And in here, I'm just gonna, now you can see Git automatically started marking this file as unstaged. It has a U. So it's new to the repository, so Git immediately picks that up. So let's say this tutorial is going well. I am definitely going to give it a thumbs up. Okay, so now we have this file, dummy.txt, it contains some text. Now let's go and do this workflow we have checked. So first, let's actually check the status, and we can see Git is telling us, so if you don't have Visual Studio Code telling you this information here, you can always just run the git status command to check what's going on. We can see we're still on the branch master, we have untracked files, so let's actually go and track that file. We can say git add, and this time I'm going to use the file name, so I'm just going to say .txt. You can still use just the dot. I'm just showing you these 2 different ways. So git add dummy.txt. Now we can see it has the A letter being marked. Now we want to run git status again. I'm just running git status a lot so that you can see exactly what is happening during this process. After a while, you won't run this anymore. But now we can see a new file has been added, dummy.txt. And now we're going to say git commit with the M flag for message. And here I'm going to say second commit. And I'm going to give it a message of some dummy text file, something like this. Okay, I'm going to run this, and we can once again see on master, we can see the commit ID, the message, what files was changed, and the insertions made in that file. And now we can run git status again and see nothing is to be committed. The working tree is clean, so there's no more changes after the last commit. So now we can run git log, and here we can see two logs now. We can see the old one that we made, the initial commit, and then this is the new one. And we can see that the head is pointing to this master version of the repository now. So now we have seen this workflow. So let's actually do that one more time, but this time let's add something in here. So I have completed all of these commands and understand them. Okay, so this is all just some dummy text, but just to show you, now we can see a M being added here. So this is no longer a new file. Git has already staged and tracked this file, but it can see something was modified in the file. So we can say git status, and now we see a little bit of a different output. We can see changes not staged for commit, but we can see a modified flag for this file. So let's actually go and change something in here as well. I'm just going to add some rubbish at the bottom and save this. Now we can see a M flag being popped up here as well. It doesn't look like it's doing it, but let's say git status. That's actually pretty weird. Did I not? Oh, I added it to the same file. Okay, let's remove that and go to the dummy and just add in here some dummy text and save. Now this should bring up an M flag here as well. So if I run git status, we can see that there are now 2 files that have been modified. So in your project, if you work on a coding project, usually in the beginning you'll have all of them as new files, and then as you start working in them you have modified flags. So this is something you'll see a lot. So let's go and stage them. How do we stage them? We say git add, and I'm going to use the all flag, because if I were to only use the checklist, for example, it won't stage the dummy. So you'll see it will only mark this one. What did I do wrong here? I did not match a file. Okay, so I did a spelling mistake. So check. I actually spelled this wrong. It's not spelled correctly, but yeah, let's just go with that for now. And say add. Now it's only going to add this file. So we can see it's modified and it has a little bit of a grayed out color now. So if I were to run git status here, we can see these changes are in the staging area, but these changes are not being tracked yet. So it's not staged yet. So let's go and stage that one as well. Dummy.txt. I need to add that, sorry. Okay. Now we can see both of them have this opacity color. Now we can commit this, git commit with the message flag, and we can say third commit. You don't need to add like what level of commit this is. This is just to show in the tutorial. And here we can say added more text to both files. Okay, we can see the commit information, and there you can see stuff, it just disappeared again. So git status, everything is clean. Git log, here we can see all 3 of these commits and their logs. So once again, the git log --1 line allows us to see the shortened version of these commits. So we can see there's 3 commits in this repository on the master branch. Okay, so I think we've covered basically all of these very important commands. So we've done a little bit of a workflow through them. So in the next part of the video, we're going to start looking at some other commands that are also important and allows us to time travel between these different commits that we made. So let's dive into that part of the video next. Okay, so let's actually go and start looking at the next commands. I'm just gonna actually go and fix these spelling mistakes, so this should understand them, just like this. And I'm gonna actually change this file so that it's spelled correctly as well. So checklist, now it's gonna say this file with this name is not being tracked, so we can just say once again git add and git commit, and I'm just gonna call this, let's actually see it has an OR flag now, so let's see what git status says. We renamed this file, so it actually picks up a rename. So now we can say git commit, and I'm just gonna commit this commit 4 and rename file. Okay, so now the working tree is clean. Now we can continue to the rest. So the next commands we're going to look at is actually the git checkout command, which is a very powerful command. But for this tutorial, we're only going to be using this to time travel between different commits to check what happened in that commit, what has changed, and so forth. The next commit we're going to look at is the git revert command. So this is a fast forward reverting tool. So it allows you to go back to a previous commit, but instead of deleting some commits in between, you actually just fast forward. You create like a duplicate version of a previous commit, and that would be the head commit. So I'll explain it as we go. So let's actually go and start time traveling with this checkout command. So I'm going to save this. We're going to have some modifications. Let's actually go and commit them. So we're getting a lot of exercise in doing this workflow, because this is what you will do a lot. So say git commit. And as you can see, I actually only start using these two commands, the git add and the git commit. So I'm going to say commit 5, and I'm going to give it a message of new commands added to checklist. Just like this. Okay, so now we have 5 commits. Now let's actually go and view these logs. So I'm going to use the one line flag, so we can see all 5 of these commits, the initial commit, second, third, fourth, and the fifth. Okay, so let's say we want to view what happened, or what this repository looked like in this first commit. So I'm going to copy this commit hash. So in the terminal, you can just select it, and then you can right click. So now I'm going to use the git checkout command, and this command has a lot of flags. So you can go into the official Git documentation and check all of the different flags that this command can take. But for this purpose, we're not going to use any flags. We're going to just use it as it is here, and we're going to paste in that commit hash. So now take a look at this file up here and what is going to happen once I run this command. We're actually going to do something magical. We're going to time travel to the first version of this project. So let's go. We can actually see something very interesting, that this file was deleted because we changed the name. And if we look in the folder directory, we can see that it went back to the old file name. So you can see it's actually crossed out here. So if I close this now, we can see a big message being logged down here. You can disable this if you don't want to view this every time, but this is basically just telling us we are in detached head mode. So we are not on head pointing to master anymore. You can see down here as well. We are actually, our head is pointing at this commit hash. So we are checking out this commit. Visual Studio has all of these nice spots to show you. So initially we were looking at master, and the head was at master, but now the head is at this commit. So you can read through this. It basically just tells you everything I just told you. I would definitely recommend, it does say you can make changes when viewing things in detached head mode. I definitely won't suggest this. This is not best practice as to use Git, because you can lose a lot of information doing it this way. This is just physically to check out the repository at a different place and time. So that's where the checkout command comes from. Okay, so here we can see this is the initial commit that we made. There's nothing else in this repository. And if I were to view git log, we're only going to see this one commit that we made, because that is where we went. We went to this one commit. So now you might ask, oh my goodness, how do I get back? And that's pretty straightforward. We just say git checkout with a minus sign. So this is telling us go back to the master head of this repository. So if I run this, we can see previously head was pointing to this commit, but now we have switched back to the branch master. So now we can see everything is back here. We can see the checklist is spelled correctly. We have all of the contents of this file, and we have the dummy with all of its content as well. So that's pretty cool, right? So now let's view the git log one more time, and we can see all 5 of our logs being printed here. So I'm just going to view the git log -- one line version. Just makes it easier to fit in. Okay, so the next thing I want to do is use the next command called the revert command. So basically what this does is, let's say we don't want this commit 5 or commit 4 where we renamed the file. But let's actually see what happens if I try and revert the commit 4. So this is a little bit of experimental on my side as well, but let's see. So I need to actually copy that git log -- one line. I need to copy that commit hash, because that's how you travel through Git. Is these hashes are always unique, and they form like this tree-like structure, and we can always jump to these nodes. So we can say git revert and then we give it the hash, and could not commit this file after resolving the conflicts. Okay, so basically we can't revert something, we can only revert the latest. So it actually did do the revert. Let's actually check this. It's in the reverting phase, and we can see in this reverting that we have a few new things to add in this file because we reverted the, okay, so it actually did do the revert. So now we can see that the revert happened, and here we can see some nice highlighting inside of Visual Studio Code. And this will happen if there's something called conflict. So conflicts meaning something changed and Git is trying to put the new changes inside of the file, but there are different things in the position where changes has happened. So now we can see we have the current change and the incoming change. So the incoming changes, I have all these commands, and here we have the rest. So I'm just going to accept both, but I'm going to remove this line at the bottom. So now we see we actually brought this over from the file that we renamed. So remember, we renamed this to checklist, the correct name, and then we added this to the correctly named file. So now it brought that in because it saw that we actually reverted the commit that we made to change the file name, but there was still new things added to this file. So Git is very clever. It actually picked all of these things up. So let's save that. You can see it has an orange exclamation mark, and we are currently on the master slash reversing, or this is not the slash, the piping character, reverting. So now we have to do a basic git add git commit again. So if we run git status, we'll see a little bit more information on what is happening in the repository. We can see we are reverting this commit, and we can run this command to cancel everything we just did. So it's nice, it gives you like these fallbacks as well. And now we can see that this file was technically deleted, but now it was, the rest of the things were added into the checklist that's spelled incorrectly again. So now we need to do the git add git commit again. So we can say git add, basically just telling git, listen, we've done this. And if we were to run git status, it would actually show that we renamed this file once again because we are reverting the previous change from checklist, which is the right one, to the wrong one. Okay, so let's say git commit, and we give it a commit message of reverted and fixed conflicts. This is, I think, the commit 6, right? So let's just add commit 6 for us to check in the logs, and I'm going to commit this, and we can see everything is clean now again. So we can run git status, we can see on branch master, nothing to commit, working tree is clean. Okay, so now let's see actually one interesting thing. So if we were to go to git log -- one line, we would think that the fourth commit that we just reverted isn't there anymore, but that's not the case. So what Git does with the revert command is it actually creates a new commit, but just copies everything that was inside of the commit you are reverting. So we can see we have the initial commit, the second commit, the third, and here we still have the fourth commit, then commit number 5, and then commit number 6. So this is a much safer way to reverting changes inside of a commit. There is another one called the git reset, but this actually physically deletes the commit, which is not really a good thing to do, because if you're collaborating with people, this could actually cause issues. So now we have gone through all of these 7 commands. This one allows us to time travel to a specific commit hash. So it's very nice to check what we have done or what has changed. But when we get to branching, we'll see a little bit of a better way of doing this. Then we have the git revert command. So we've done something wrong. We just made a commit and we realized, oh damn, this was wrong, and we want to revert this commit. Then we use this command with the commit hash. So in the next part of the video, we'll actually start looking at branching, merging, and then we'll do a little bit of a workflow around that. And with the rest of the tutorial, we'll definitely be using all of these commands. So make sure that you are comfortable up until this point of the video, and then we'll continue on. See you in the next part. Okay, so now let's start looking at branching and merging. And we're going to do a little bit of a workflow around that. So initially, every time we run this command git status, we can see that we are on branch master. We can see the master branch over here, and down here we can see that we're on master. So Visual Studio Code makes it very clear that we're on master. And when working with branches, it's important to know on what branch you are. So that's why I think Visual Studio makes it obvious, so that developers always know where they're working from. So the idea behind branching is the following. I'm going to do a little bit of bad drawing for you guys so that you can see. So let's say the yellow represents our master branch. Okay. So up until this point, let's say we are at this big dot. I'm going to make smaller dots for the commits. So we had, I think, 6. So let's make 5 more. Oh, that's very skewed, but anyway. Okay, so these are 5 commits and then the 6th commit. But we realized we don't want to continue making commits on this main branch. We want to actually create a new branch, do a few development or do a few extra work on that branch, and then once we're done, we want to merge it back in to the master branch. So the idea behind that is going to look as follow. We're going to make an exact copy of the current position we're at, the current branch. So we are at commit 6 on the master branch, and we want to start working with branches. So we're going to create a branch that is a direct copy of where we are. And then we're going to start making commits on this branch. And once we're fine with where we are at this branch, so let's say we're at this position and we're fine with what we've done, then we want to merge it back into the master branch. So then we'll get to this point over here, and this will happen. We'll basically merge everything back in here, and then this master branch will then be synced from here. So it would look like a lot of things happened between these two commits, but it's actually a branch that was merged into this. You'll actually also see all of the branch logs in between here. Oh, that's way too big. We'll actually see all of the logs information of these directly being translated there. So I hope this little drawing makes sense, but let's actually dive into using these commands, and maybe this will start making more sense. So currently we're on branch master. So the first question would be, okay, so how do we create a new branch? So I'm going to show you how we do that. We use the following command. So I don't think I added it here, so let's actually add it here. Using branching and merging in Git. And then the commands we're going to cover are the following. It's git switch to switch to a branch. Then we have git branch, and this basically logs out all of the branches that we have and the one that we're currently working on. And you can do a few things, but we'll just do the basics of this that you need. And the next command is merging branches, so the git merge command. So let's go and cover them right now. So I'm actually first on this current master branch. I'm going to commit everything I added to this file. So once again, git add, git commit with a message. This is commit, I think this is 7. And then added merging and branching commands to file. Okay, so we are used to this output by now and that workflow. So now let's create a branch. So it's the first one, the git switch. So I'm just going to close that out. And I'm going to use the git switch. And if this branch doesn't exist, so let's actually first do the git branch command. So we're going to say git branch. And if we run this, we can see it outputs master with an asterisk. So this asterisk is just telling us what branch we are on. So basically, if it says master here, the asterisk will be at the master branch over there. So let's create a new branch. So we can say git switch. And now we saw that there is no branch with the name, let's say branch 1. We'd call it branch 1. So we say git switch with a name. But we know that branch 1 doesn't exist because we just checked all of the branches. So we have to add a C flag for create. So git switch with the C flag will go and create this branch and then switch to it. So if I run enter now, we can see switch to new branch. So it's a new branch. and we switch to branch 1. So now if I were to run git log, we can still see all of the commits from the previous branch. We can see all of the commits from master. So here we can see the head is pointing to branch 1, and it's on the same level as the master branch. So nothing has changed from branch 1 to the master. So this is why it's on this, it shows us this output here. So I'm just gonna quit that. The next thing I want to do is check the status. So git status, we can see on a branch, now we have a different branch here. We're on branch 1, and we can see it everywhere being logged in Visual Studio. So, and there's nothing new here. So this is very cool. Now we are completely separate from the master branch, and we can continue working on this branch without affecting the master branch. So I'm going to actually add a new file in here, and then these things will start becoming clear. So let's say branch, or let's call this chapter1.txt. And I'm just going to add I can't do lorem here. I'm just going to add this is the first chapter of using Git branches. Okay. So we have the same type of thing. So now we have the Git telling us this is unstaged. So if we were to run git status, we now see everything exactly the same as that we did when we were on the master branch, but now it's only specifically for this branch 1. So we can see that there's untracked files for this branch, and it's this file. So let's actually do our entire workflow that we already know by now. It's the git add, and we're going to add the chapter1.txt, and we've added that. I'm just using the name there to switch it up a little bit. And then we have the git commit command with the M flag, and we can say this is commit. Let's call this commit 1 on branch 1. Okay, so we can see we made a branch 1 commit. This is the commit message. We can view the message and the files that was changed and so forth. So now if I were to run git log, I'm just going to use the one line, so the shortened version. And here we can see a different type of output than we did last time. So here we can see everything that the master branch had, because like I said, we make a direct copy. So I don't know if I have this. No, it's not there anymore. This drawing, let's see. Yeah, so I still have this drawing. So we made a direct copy here of the master branch, and then we started adding commits here. And what this output is telling us here is that the master branch is on this commit. It's on commit 7. But now the head is pointing to branch 1, which is on this commit. So you can see there's a difference between these two. So if I were to actually show you this, I'm going to use the git switch command now to actually switch back to the master branch. So let's actually run git branch and just check this out. We can see there's 2 branches now, and the asterisk is on the branch 1. So let's switch to the master branch. So we say git switch. This time we don't need to specify the C flag, because we don't need to create this branch because it already exists. So we want to switch to the master branch. Here we can see we have switched to the master branch, and if you checked up here, you will see that chapter 1 has disappeared. So this is pretty cool, right? Because now we can see, if we actually were to do the git log -1 line, we can see that it only has up until commit 7. So no new commits was added to the master branch. It was only added to the branch 1. So let's actually go back to the branch 1 and do a little bit of, so let's say git switch branch 1. Okay, we're switched to branch 1, so now we're getting used to switching between different branches, and there we can see this txt file pops up again. So this is pretty neat, right? I mean, doing this without Git, I don't even know how we do it. You would have so many folders and different versioning and stuff, so this is great, all from the command line. Okay, so let's actually go and add a few things in here. New work added to chapter 1, and let's say end of. Okay, let's actually make commits on each of these, so we can see it's modified again. So we can say git add, git commit. So I'm just gonna speed through this, just follow along, and then we can say this is the second commit on branch 1, And we can say that what did we add here? Just gonna create that space a little bit smaller. And new work added to chapter 1, something like this. It's just some arbitrary text, and as I said, these commit messages should make sense to you and the people that you work with. Okay, so we created the commit. Let's finish off chapter 1. This is the end of chapter 1. Save that, do the commit, run down again. So git add, git commit, and third commit on branch 1, chapter 1 finished. Okay, so now we have made a few more commits. So let's view the logs. Git log -- 1 line. I know I speed through that a little bit. If you need to pause and catch up, then do so, but I do suggest staying with me. So, okay, here we can see that the master branch is 3 commits behind. So the master branch doesn't have any of these 3 commits or the changes that happen in them. So let's actually go and create a chapter 2 file. So chapter 2.txt. This is chapter 2. We can save that. We can see it's untracked. So let's actually go and say git add chapter -2. And we can say git commit 4, I believe, on branch 1. Started working on chapter 2. Okay, so you can make these commit messages what you want. So now if we were to go back to the master branch, none of this work will be there. So you'll actually check up here that these 2 files would disappear. So git switch, and we'll go to the master branch. Boom, they are gone. So this is pretty neat, right? So now we have decided, okay, we are done with branch 1. Now we want to merge branch 1's work into the master branch so that we have the full source of truth on the master branch. So this is where we get to the next command, the git merge command. So git merge, we say git merge. And the important thing with the git merge command, so if I were to go back to my drawing over here, when we use the git merge command, we are at this position right here. So we want to start merging this work from branch 1 into the master branch. So in order to do this, we need to first be on the master branch, and then we use this git merge command, and then we tell them what branch we want to merge in. So it's important. First, we need to switch to the branch we want to merge something into. So if I were to illustrate this, we can't be over here and say git merge whatever's in here in there. We need to be on this branch and then tell git with the git merge command we want to merge this branch in here. Okay, so I hope that's clear. So let's continue. So now we're on the master branch. If we say git log, we can see that none of those commits that we made was there, and we can see the head is pointing to the commit 7 on the master branch. So let's say git merge, and then you specify the branch name. So we say branch 1. And here we can see output being made. We can see these 2 files was brought in, and here we can see a fast forward happening. So we saw an update from this to this. And then we can see a fast forward. This is always a good sign if you see fast forward. We'll get to conflicts in just a second, but this is always a good sign. And then we can see chapter 1.txt with 5 insertions and chapter 2 with 1 insertion. So there was 2 files that changed, 6 insertions occurred, and here we can see both of these files was created with the non-execution files. Okay, so this is great. Now if we were to run git status, we can see the branch working tree is clean. And if we were to run git log --1 line, now we can see an interesting output. We can see that all 3, so this is the commit 1 from branch 1, second commit, third commit, and fourth commit. So now all of these commit messages have been merged into the master branch as well. So this is nice because now you can see where things has happened. And here we can see the output again. Our head is pointing to master, and master is now at the same level as the branch 1. So that means if we take a look at our terrible diagram here, I hope it's not too terrible, but we can see that it's now on the same level. These commit messages that I pointed out over here was merged in, and we are at the same level on the master branch. So let's actually go switch back to the branch 1, and we create something called a merge conflict. So this is something that occurs a lot of times in development, so it's always good to know how to resolve them or work with them and know what happens when they occur. So in here, in chapter 1, so now we know that the master branch has all of these files, so it's synced together now. So if we were to run git log again here on this side, we can see that they're pointing to the same thing. So now, if I were to change something in chapter 1 that's not in the master branch and then merge them in, we would get something called a merge conflict. So I'm going to change this line. I am creating a merge conflict from branch 1. Let's just say branch 1. Okay, so what I'm going to do here, I'm going to commit this, git add, git commit. This is commit, I think, 5 on branch 1, creating a merge conflict. Okay, so we've made our commits. If we say git log, we can see that this commit was added. We are one commit in front of the master branch. So let's actually switch back to the master branch now. Switch to master. We're on the master branch now. Now, if we go into chapter 1, we don't see that output I made here. But now I want to do something on the master branch, let's say for some reason, and I add something that is not the same as branch 1. And I save this. I then go and create a commit. So I say git add, git commit, commit 8, master changes. Okay. So now we want to do the merging again. So we want to take what is from branch 1, the changes in branch 1, and pull it into the master branch. So we're going to say git merge branch 1. And oops, we see something here. Once again, we see that orange that we saw previously when we renamed the file. So here we say auto merging chapter 1 txt. There was a conflict in the content. The merge conflict in chapter 1, automatic merge failed, fix these conflicts and then commit the result. So we can see that we're on a slightly different thing here. We're on master with the pipe character and merging. So there's something, we're in the process of merging these two branches, but something caused a conflict. So if we go into Visual Studio, we can now see this output again. So Visual Studio makes this very visual and nice to view. If you just do this from the terminal, I don't believe it's this visual, but here you can see a nice output this way. So we can see the head or the current. We have something that is not the same as branch 1. And then we have something coming from branch 1, which is the incoming changes. So this is the current changes on the same line. And then we have these changes. So it's telling us, listen, these two things are on the same line and they aren't the same. So something is going to override something else here. So this current changes is going to be overwritten by this I am creating a merge conflict from branch 1. So in order to solve this, we have these few steps that we can take. We can say compare these changes, which it's basically already doing. You can, if you compare it, it gives you side to side. Both of them are on line 3. And you can see on the current, it's saying, or on the thing that we want to merge in, it's saying this. And on the current, it's saying this. So I'm just going to view that again like this. We saw a nice comparison there. Here we can see an option to accept both changes. So if I were to click this, it would actually go and just add both of these statements in the in the current file, or we want the accept the incoming changes, which is coming from branch 1. So then it's going to delete the current changes and add this in there instead, or we want to ignore the branch 1 incoming changes and use the current changes. So usually you would go for the accept incoming changes. This can be very niche depending on your situation, but in this situation we want to pull in the things from branch 1 so that they are in master. So I'm just going to say accept incoming changes, and here we can see that message. I'm creating a merge conflict from branch 1, and it is now inside of the master branch. So I'm going to save this, and then I'm going to say git add, git commit, and then usually we give this message merge conflict resolved. Okay, and we can see the master with the commit and then the message. So now we can see everything is up to date. If we were to say git status, the working tree is clean, git log -- one line. Here we can see a few things. We can see that we made a commit on the master branch that's not inside of the branch 1, so that's why it's behind like this. And then we made a merge conflict commit on the master branch to when we merged everything from branch 1 into master. So now you might ask, okay, so these two are behind, so they are not on the same level. So how do I get the things from master into branch 1 so that I continue on branch 1 with the up-to-date code base? So let's actually git switch to branch 1. I hope you guys are still following, but we're switching to branch 1 now, and we can view the log. So git log -- one line, and we can see we are at commit 5. But this chapter 1, these commits, so this commit history is not up to date with the master branch. So we can get it up to date by basically doing the same, but in reverse. So now we're going to merge whatever's in the master branch into the branch 1. So I'm going to say git merge. And remember, we are currently on the branch that we want to merge to. So we want to merge the master branch in. So we can see it updated the commits, and it was a fast forward merge. You can see no files was added, no insertions happened. But now if I were to say git log -- one line, we can see that they are synced together. So now all of these commit message 8, 5, all of them are inside of the branch 1 as well, and we can continue working on the branch 1 and doing changes and then merging it back into the master branch. So this is very powerful because now we are completely detaching our workflow from the master branch or some different branch. You can create as many branches as you want. You can create a branch from branch 1. So if you were to want to create so we are currently on branch 1 over here, and we want to create a new branch from branch 1, we can go ahead and do that, and we can start working from here. I'm going to make that smaller. We can start working and adding commits in here, and then once we're done, we can merge these things back into the branch 1 over here, and then we can actually go ahead and merge that back into master. So you can do this entire workflow, but usually in Git we do something called feature-based branching. So we'll create a feature, which is this blue part over here, and then we'll merge that feature into our main code base. So that's basically the idea behind doing branching. So, and all of the other commands that we've learned from Git, you can do that on any branch. So if we want to revert a commit, so let's go to the git log -- one line, and we want to revert, let's say, this commit 5. We can copy that commit message. We can say git revert, and then we paste in that over there. And here we can see it opens up this this event. We can give it a message that we want to revert to. I'm just going to press enter here. This is in the nano built-in terminal. Just going to save and exit. Here we can see we created. You don't need to do this, what I just did. I'm just going to show you what I did here. Basically, if I were to say git log now -- one line, we can see on branch 1 we made a revert, we committed, so we basically reverted the commit 5 on branch 1. So I don't remember what we did exactly here, creating a merge conflict. Okay, so in here we can see that it doesn't have that text creating a merge conflict anymore. And if we were to say git status, we can see nothing new on this working tree. So now if I were to go back to master, so git switch to master, and I want to sync these two branches again. So on master you can see this changed, but now I want to merge, so git merge branch 1 into master again to get the updated text. We can see it gave me a fast forward merge, and it basically just changed everything back to the original form. So there was no merge conflict because there was nothing new being added. We just reverted a change, and then Git magically puzzled everything together for us. So I hope this section on merging made sense to you guys. I would suggest playing around with it, creating more branches and doing things and merging it back in, and just get yourself into trouble. Do things obviously on a small project, not in a big code base, but play around with these things and you'll get comfortable with them very quickly. But the next part, we're going to start looking at using Git and GitHub in collaboration with each other to do some nice things and very, very powerful things. So I'll see you in that part of the video. Okay, so the next part of this tutorial, we're going to be covering GitHub. So if you have not got a GitHub account and not set up your local Git to work with GitHub, then I would suggest go down in the description. I have a link there, a blog article that shows you how to do this setup. It's very straightforward. And if you have that, then we can jump right in. So what exactly is GitHub? GitHub allows us to take our local repository. So I'm going to do a little bit of a drawing again. So let's say this current project, this is the one we're working on. This is our local repository. On this local repository, we have all of the branches, we have all of the commits, and so forth. Now we want to save this branches and commits and everything to a remote repository. So we can push our code to this remote repository and pull down any changes that was made. And the pulling down can be either you switching a device, so you're not working on your work computer anymore and you want to go to your personal computer, then you still have the code base and you can travel with it by saving everything to GitHub. It's like using OneDrive to save your files, but GitHub gives us a lot of functionality. And one of the great things is, let's say we're multiple people, so we have another team, a few team members that's working or collaborating on a project, then we don't need to share the code via email or zip files or USB drives and stuff like that. We can just save it to GitHub, and then everybody can pull down the latest repositories, work on their branches, and so forth. So let's actually, now that we kind of understand what GitHub is, let's actually start working with it. So here I am logged into GitHub. This is my GitHub profile. And at the top right, we can create a new repository. So just like you would create a repository on your local computer, you can now create a GitHub, which is basically a remote repository. So we can give the repository an owner, so that would be me. We can give it a name. I'm just going to give it a name of Git and GitHub. Tut for YouTube. And you can give it a description. This is a tutorial on using Git and GitHub for everyone. Okay, then we can decide, should this repository, because remember, this is a remote repository, so someone else can access it, or we can set it to private. So then only you and the people you add to this repository can access and work with it. I'm just going to keep it as public, and we can initialize a few things in this repository. A readme file, a git ignore file, or a choose a license type of document. So we're going to keep all of those unchecked, and I'm just going to say create repository. Then we are greeted with this screen. So this screen gives us a few commands. If we were to look at some of them, they would look familiar. It's the git init, git add, git commit, git branch, and here we have a few different ones, the remote and push. So we'll get to them right now. So I'm going to stay on this page and I'm going to navigate back to the project. So in here, we now need to connect our local So if I view the image again, we need to connect our local to this remote. And how do we do that? Well, if we actually go to the screen, it actually tells us how to do it. We need to say git remote, add origin, and then the string. So the string is a link to that repository. So I'm actually going to go into our checklist file here, and I'm just going to say GitHub related commands. So there are going to be, let's see, it's the git remote command, it's the git push command, and it is the git pull command. These are probably the most used 13 commands you'll use when using Git and GitHub. So we are going to be covering these to work with GitHub. Okay, so the first one is the git remote. So remember, this is a local repository we are currently working on, and we want to add some remote repository to basically sync the data in between. So we can do this with this command. We can say git remote, and then we can specify our option add, and then we can add any remote repository. And we're going to name this remote repository. Usually, in like if you were to view the documentation here, it adds it with the name of origin. So we can also do that. You can name this whatever you want. Just remember, it doesn't matter, but usually it is origin. So we can say git remote add origin, and now we need that string that connects our repository. So this SSH string. You can use the HTTPS string, or you can use this SSH string. I would suggest using the SSH string because some of the functionality of HTTPS was deprecated. So now I'm going to paste that in here, and I'm just going to press enter. You won't get anything logged back to you, but now if we were to say git remote and just run it as this command, we can see we have one remote and it's called origin, and now we can actually start working with this GitHub remote repository. So I'm actually going to save this file. We can see it was modified, so I'm going to do my local jazz we always do. So I'm going to say git commit, git add, git commit, sorry. And this is GitHub commands added. Something like that. Okay, we are used to that message by now. Okay, so now everything in our local is up to date. So if we were to run git log -- one line, we can see that branch 1 is one commit behind. It doesn't have this current commit changes that we made in the checklist. So that's fine. But now we want to push this repository or this branch, so the master branch, we want to push that to GitHub. So how do we do that? That's with the next command we're going to be checking out, is the git push command. So we can say git push, and then we specify the origin. So, or the remote repository we want to push to. So you can have multiple remotes. You don't need only the origin. You can have like an origin, you can have like a GitLab, a Bitbucket, or any Heroku, any servers, and so forth. So for this part, I'm going to specify the origin because we only have the origin remote. And then we want to specify the branch. So we want to push the master branch. So I'm going to run this, and you'll see a few things running. I don't know the specifications of all of these, but at the end we can see remote resolving deltas 100% done, and we can see a new branch was created. It was mapped to master, and it was added to this remote. So we added this string under the origin flag or origin variable. So we don't need to add this string the whole time. We can just type in origin. So now if I were to run git log -- one line, we can see something else being logged here. We can see the head is pointing to master, but now we have something called origin/master. So this is basically our local master, but on the remote. So this is pretty cool, right? So if we were to go back to GitHub now and refresh this page, we'll see something cool. Look, there is our code. Our code is on GitHub. So now we have the ability to communicate with GitHub and pull down new code. So let's actually go and push we can see that there's branches over here, but there's only one branch. It's the master branch. Now we want to add a new branch, and this would be the branch 1. So let's switch to the branch 1. So git switch branch -1. So now we're on branch 1. We can see branch 1 does not have the new updated checklist. So let's actually merge from our local. We can say git merge, and we want to merge the master in here. So it was a fast forward merge, the checklist was changed, and here we can see the new changes being added. So this is all good. Now we want to push this changes to GitHub as well. So what command do we use? The push command. So we can say git push origin and then branch 1. And we can run this. It's going to give us the same type of output. And at the end we can see a new branch was created, branch 1, and it's mapped to branch 1. If I were to run git log now, --1 line, here we can see that branch 1 is at the same position as master and as the same position as the origin branch 1. So now we can see a few things being logged out here, but we understand what it means now. So at least it's not like completely overwhelming. So now if we go to GitHub, refresh the page, we should see there is now 2 branches. So if I click on this drop down, we can see branch 1, and we can switch to branch 1. We can see all of the things here, and we can switch to branch master. So the idea behind using branches with GitHub and collaboration is as follows. I'm going to do a little bit of a drawing again. I'm going to remove all of this. So at the end of the day, what happens is, let's say we have a team. So this is Bob, this is Susan, and this is Jack, and this is Joe. Okay? And they want to work on a project. So we're going to start and build our project on GitHub. So everybody can start pulling down all of the code base. So they all have the same code base. Then we can say the person down here starts working on some branch. Let's call it branch A. Okay? And branch A has some feature. Then this person works on branch B, and branch B has some feature. And then we have this person working on C and this person working on D, each having their own feature. And at the end of the day, all of them can go and push their code back to GitHub on different branches. And then on GitHub, it allows us to do something called a pull request, which is only specific to GitHub. So if I have to explain what a pull request is, it's basically merging everything, all of the branches that these people created, it's merging all of this into the master branch. So we never actually directly work on the master branch. We make our separate branches, branch A, branch B, branch C, branch D. And then at the end of the day, over here, we have the master branch. And then we take all of these commits that was made to GitHub and we merge it into the master branch. Now, the next morning when this team starts working again, each one of them then again pulls down the new master, they create their branch from the master branch, and they start working on something else. So that's the idea behind this, and it makes collaboration, saving code, versioning code very, very easy. Okay, so let's actually try out one of these workflows I just talked about. So we are currently on branch 1. So let's say I am person A and I am working on a new feature. So let's actually create a new branch. I'm going to switch back to master. Okay. Now I want to create a new functionality from the master branch. So the first thing I want to do is say git pull, which is actually the last command we want to check. So git pull basically just means we pull down any changes that is on the master branch that we don't have. And you can do this for any branch. So I'm going to pull this down. It should say everything. Okay, so I actually have to say the repository as well. So I'm going to say git pull origin and then from the master. So everything is already up to date with the master. So the idea would be I'm going to actually go to GitHub to the master and I'm going to change something in here. I'm going to add text. So you have the ability to do some editing here. I'm going to say this was added new to the master branch. Okay. I'm going to do a commit. You can do all of this. Is basically like a GUI version of doing the things we did in the terminal. And this is doing it on GitHub. So I'm just going to commit everything. Okay. If we go back to the repository here, we can see we had 17 commits. The latest commit was update chapter 1, and we added this. This was added to the master branch. Okay, so that's everything good. But now our local master does not have those changes. So if I go to chapter 1, we don't see the comment I just left there. So how do we get from the new stuff from GitHub to our local? That's by running the git pull origin master. So the same as we would do with push, we do it with pull now, and we'll see that there was a fast forward merge. So this pull basically merges the changes as well. So it pulls down the new changes and it merges it. So that's pretty nice. Okay, so here we can see that we have the most up-to-date things. Now we want to create a branch from the new master branch. So I'm going to say git switch with the C flag, and I'm going to call this feature A. Now we've switched to feature A branch. This branch is not on GitHub, but let's actually go and do a few changes. I'm going to go in chapter 1. I'm going to add, this is some local changes on the feature A branch, or any other code that you would add to a project. I'm going to add a new file. Let's call it chapter3.txt. This is the start of chapter 3. I'm going to save that. Let's go into the dummy text. Let's copy this and add a few more things to this. So I'm basically working on a feature in quotation marks here, adding a few things. This is feature A. Now we can go git push, or let's actually do our basic workflow is git add, git commit, and we want to create a commit message, feature A complete, and we can now push this. So we can say git push to origin, and we want to push the feature A branch. It's going to show us our output. We created a new branch, feature A, and if we were to go back to GitHub now, let's actually go to GitHub. We can now see feature A had recently been pushed less than 1 minute ago. So if we view, if we refresh this, we should see a new branch. We have feature A branch. Now we can go to this tab over here called pull request. And basically what this allows us to do is create a new pull request, and we're going to merge something into master. So it's basically like doing it locally, but here we can do a few tests, check out the code, and so forth. So we're going to go to the feature A branch we just pushed, and we want to merge that into master. And here we can see some of the changes that was made. We added a few more text, we added this chapter, this is a new file, and we can see we are able to merge. So I'm going to say create a pull request. We can leave a message to any tech lead or someone like what we did in this commit, and we can say create pull request. Now our tech lead can go to this pull request tab. They can see, okay, we have a new pull request from Lloyd. We can view this. We can view all of the commits that were made in this pull request. It's actually very, very nice, and I would suggest playing around with this, but then at the end of the day we can actually merge this in. So we can say merge this pull request into the master branch. So we're going to say commit into master from feature A, and we can say confirm message, and we see the pull request successfully merged and closed. So now there's no more pull requests, and if we go back to the master branch on GitHub, we can view the following changes. We can see there's now a chapter 3, and we can see that in the dummy file more things were added. But now our local master is not synced to these changes. So now we can use that pull request again. So we can see chapter 3 is not here. We can either go to our local and say git merge, and we want to merge feature A. But this is a little bit more if you're working alone. So if you're working in a team, then you would most probably want to get the latest from everybody's commits to the master branch by saying git pull origin master. Now it will pull in all of the changes and it would merge them. if there was any conflicts, it would show up the conflicts, then you just have to fix that. It was a fast forward merge, all of these changes were made, and now we have all of the latest and greatest stuff on our local computer, and anything we can start a new branch from here and start working on some other feature. So this is the main idea behind using GitHub. So I know I kind of sped through the GitHub part, but it's basically Git, but on like a remote repository. So you do the same commands, the same ideas still exist. So if you do a pull request, it's basically like just merging some branch into some other branch. In some cases, most companies, they would work in the following type of situation. So let's say the red is the master branch. So we have the master branch over here, and then we would create different branches. So this person is working on this functionality, this person is working on this functionality. They both have the same position of the master. I'm just going to actually align that so it's more clear. So they actually work from the same position from master. They do something. This person A then merges their changes into the master branch. So the master branch is starting from here. The yellow person then goes and merges their changes in over here, and then the master branch can continue. So the master branch is not directly worked on. We just use it to pull down any new changes. We create a branch from the master branch, and then we continue working from there. So there's different methodologies to using Git and GitHub and how you branch, and that's something you can go and check out on your own time, and this sometimes differs from company to company, but this is the main idea. And I really hope that this video made you see that using Git and GitHub is actually not that bad. It's really powerful, and it actually, as you get used to it and play around with it, it would actually save you so many times. Like if you do something wrong, you can just revert a commit, or you can just pull down the local changes. You can destroy your branch and start over from some base point, and it basically it's really cool. So I really hope you found this video helpful. If you did, please remember to smash the like button. Leave me a comment if these drawings was clear and if you didn't understand anything. And yeah, first of all, I just want to say sorry that I've been away for so long. It's been a really busy and rough time. So yeah, I'm gonna try my best to stick to a YouTube schedule for once a week a video. It's gonna be pretty much the same type of videos where I just cover some topics. And yeah, if it comes to building things, I might break that into more smaller portions so that it's more maintainable for me and for you guys. So yeah, with that out of the way, I hope you have an awesome day, and then I'll see you in the next one. Cheers.